Well, Natural Resources class, here we are, last video lecture. Yeah, it's been an interesting semester. First for me in 31 years, 32 years, whatever it is. So we're going to finish up today, coming back to this state. We're on metals. I don't always get this far in class, so we're going to just sort of focus in on some aspects of metals, some of those relating to Minnesota, and in particular the the Iron Range. I want to just start by sort of setting the stage by considering metals generally. You know, if you ever wondered why, I think I've mentioned this in the class before, why don't we see gold mines everywhere? If you think about all the gold mining programs on TV, they're usually in Alaska, the Yukon of Canada, Montana, might be South Dakota, Black Hills area, Australia. Though there are certain areas where those mining programs tend to be. Why don't we see gold mining programs in Iowa? Why don't we see gold mining operations in Nebraska? Well, it has to do with the fact that gold is in all those places. If you pick up a handful of soil from anywhere, there is gold in it. It's just not much. And so if you look at your notes here, this is the issue. It's everywhere, but where is that metal, where is that material concentrated enough to justify extraction? And that's what we call an ore. It is a mineral deposit that is concentrated enough to mine. You might ask, well, what does that look like? Well, here's some pictures. This is gold in quartz mineral. So there's two different minerals. This is gold and this is in quartz, and some more down here. This actually almost looks like pyrite to me. I think it's just a bad picture though. This is actually gold in quartz. Gold and quartz often do come together. That doesn't mean if you find quartz you're going to find gold. It means that if you're going to find gold, it's often associated with quartz. Quartz being one of the most abundant minerals on Earth. This is what silver looks like in a concentrated form. Okay. And then here, if you're going to the UP of Michigan, the Keweenaw, that's copper country, and this is what copper can look like in a vein deposit in that part of the country. They're looking at copper nickel mining in northern Minnesota. Again, I believe one of the groups is going to be addressing that topic in their paper. Yeah, so this is what those deposits can look like. This is not the only way they're found. For instance, it's common to find gold having been weathered out of the quartz rock that it's found in. Weathering processes like ice cracking this rock apart, abrasions, other rocks being thrown against it by water or wind, is tumbling down a stream and broken apart. We'll chip little pieces of gold out and carry that gold downstream and deposit it in areas where heavier elements will settle. And that's why you see gold miners so often working in streams, because the streams will be an actual natural sorter of that heavy sediment. Anyway, that's what people are after. That's an ore. There are a number of processes here that can cause the concentration of a particular element. I'm not going to go through the first three. We're just going to talk a little bit about number 4 because this is pertinent to northern Minnesota. Basically, northern Minnesota used to be underwater. And here's a map that attempts to illustrate that. So here's North America times past, as you can see, over almost half a billion years ago. Northern Minnesota would be right here. Actually, on this map, it has northern Minnesota high and dry, but there was a time when, like the rest of North America, it was underwater, and this is the equator. Imagine that. Minnesota was actually equatorial. We can find evidences of that because of the fossils we find in rocks in Minnesota were equatorial. But I digress. I want to just kind of concentrate on fossils we would find in northern Minnesota in the Iron Range. So these are some fossils that we would see there. This is a gastropod. It's a snail. This is a shark's tooth. Another snail there. So there are evidences that northern Minnesota used to be underwater. And so it was also equatorial, which made it hot. Okay, hot and wet climate dissolves everything out of soil except the very insoluble ions, like iron and aluminum, as it's read there. Now, that is not an unfamiliar process to you, I trust. If you remember when we talked about tropical soils, laterite soils, tropical soils. Here's a picture. I'm not sure if I use this exact one, but this is a picture of tropical soils. Very thick soils, very thick layer of soils, highly leached, if you remember that. Lots of warm water percolating through that soil profile and dissolving away everything but the most insoluble. Insoluble means hard to dissolve elements, and those hard to dissolve elements would include and chiefly be represented by iron and aluminum. Okay, so when in times past Minnesota was under a warm equatorial ocean, those weathering processes were affecting the sediment here. So these warm equatorial seas were dissolving everything out of the surface sediments except the stuff that's hard to dissolve, and in the case of Minnesota, that was iron. Iron got left. We would call those deposits, if they had a lot of aluminum, we would call them bauxite, and if they have a lot of iron in them, we would call it hematite. Well, there's other things we'll call it too, but hematite is the main thing that we find in Minnesota. Okay, and so we're going to jump down here then to iron ore, because that's really what we're looking at, iron ore. So if we look at some pictures of iron mining in Minnesota, this is a good panorama of, I believe, the iron mine near Hibbing, and you can see a reddish hue to all the soils. We call it hematite, and you can associate that with hemoglobin. Hemoglobin is the protein in your blood that carries oxygen. It has a heme group, which is iron, which can mean it contains iron, and it has to have iron to be able to bind loosely the oxygen that's carried to your tissue. So there's an association in the name. Hematite is one of the three main iron minerals, and is actually the main one that is currently being mined in northern Minnesota. Okay, so if we look at those minerals, I'll come back to this picture. If we look at those minerals, I'll show you a picture of them. Here is magnetite. This is the highest grade iron ore. By highest grade, I mean it contains the highest percentage of iron. Hematite is probably the most common, but doesn't contain as much iron as magnetite. Magnetite is called magnetite because it will actually attract a magnet. It's over 60% pure iron, up to 80% iron in some instances. So, and then we have limonite, which is sort of the lower grade iron ore. Siderite is iron and carbonate. So this is what you might find in a Missouri cave, for instance. It's a significant source of iron, don't get me wrong, but not one that's largely mined because it doesn't usually occur in large deposits in one spot. So mainly these three, magnetite, hematite, and limonite, are the main iron ores, and hematite is of those probably the main one being mined now. I might also put in there pyrite, fool's gold. It's another iron-containing mineral. It's actually iron sulfide. There's no gold in it, but it has a very gold appearance, but it's not usually mined. So we're just going to consider these three. So in your notes, if you look at it, I mentioned those three, and they're made into iron chiefly in the process of mining and processing that ore in northern Minnesota. Iron is defined as having very, very little carbon, almost pure iron. It's very brittle, it's very hard, but if you dropped it, it might shatter. Steel contains a small percentage of carbon. Different types of steel. Some steel is more brittle if it has only a little carbon. Some steel is more flexible if it has more carbon. Those are things that the amount of carbon can do for a steel. But steel is definitely more durable, if you will, than is iron because of that flexibility. Cast iron is 2 to 4% carbon, and once again you have a very heavy, brittle type of material. Isn't it interesting that just a little variation in the amount of carbon can make such a different metal? Cast iron, again, if you drop that, it might shatter like pig iron or iron. The first one there might be also called pig iron, might do. There are two kinds of ores mined in Minnesota. Natural ore was the first one that was probably truly mined in Minnesota. See, I think I wanted to go to another picture for you. Yeah. And this is a northern Wisconsin, yeah, near Hurley, northern Michigan look. But this is similar to what you would see in Minnesota. These layers of rock that were originally formed. Oops, didn't want to do that. That were originally formed horizontal to Earth's surface, and then because of tectonic forces moving them, shifted them in this orientation. So that's what that ore looked like. In northern Minnesota, these pockets, so for instance, there's iron mixed with quartz deposits here, and so let's just say, for instance, this was the iron containing vein of ore in this. It's easy to see why, where at first you could just get this off the surface, but pretty soon you had to go underground and sink a shaft down and what they call drift into the vein of ore to get at it. So early on in Minnesota, northern Minnesota, it was dominated by underground mining that was trying to get at what was called a natural ore, a lot of magnetite in it, about 60% pure iron. So we're talking about real high iron concentration. And it was also important because if you look under natural ore there, because in that early ancient warm ocean, it was also, how should I say this, converted into an iron that had lots of oxygen in it. Now, oxygen and iron we're familiar with on our car, that's rust. That's a bad deal. But in the steel creating process, it's a good thing. Here's why. You're probably familiar with the term blast furnace. So here is a blast furnace. And so basically you have iron ore, magnetite or hematite, dumped in here. Coke, which is purified coal. This is coke right here. So if you take coal and you heat it to drive off water and further concentrate the carbon, you'll create coke, okay? So coke is the main fuel that's used in a blast furnace. That goes in. And limestone, well, limestone goes in because it is there to absorb impurities and form this slag right here. So that all goes in. And then hot air is blasted in, lots of oxygen. So the combustion is going to happen better if this iron ore that goes in there already has oxygen in it. And the stuff from northern Minnesota does. That's what makes it really good ore. So it goes in, it gets heated to melting. The limestone will gather the impurities and form a slag that'll be poured off that hole. The molten iron will come off the bottom and be used for all the things that requires steel. So originally then, this process was using natural ore, but there were a couple of issues. One, the other 20 to 40% of natural ore was variable, and so that was a little bit hard to control the product. Also, this concept that the ore was required miners to go underground, they got so deep it was harder to go underground farther to justify the expense of getting it out. And a new technology came along that really put those underground mines out of business, and that was the second thing there, that is taconite. And taconite is what you see in this day and age. For instance, well, here's a picture of taconite. But wouldn't those make little great little slingshot pellets? Basically, what happens here is the iron is crushed. The iron ore is crushed. Let's see. And ground up into a fine powder, and then an electromagnet will pull the iron out and leave the non-iron behind, and then that iron powder, and it is a fine powder, will be ground into, well, it is ground up, but it'll be combined with clay and then baked and hardened into these balls. That's what these are made of. That's a taconite pellet. And if you go to Duluth, if you're coming into Duluth from I-35, This is I-35 here coming into Duluth. On the right-hand side, you'll see these piles of taconite sitting there. And here's an ore ship on the other side getting loaded with taconite. And maybe you've stood under the lift bridge on Canal Park and watched one of those 1,000-footers go past you. It's an impressive sight. That's what it's shipping. Is taconite. Taconite is kind of a Minnesota term for a non-concentrated ore, and it generally tends to be about half the iron content of magnetite, of natural ore, somewhere around 30% pure mineral. But it is what's currently easily mined in surface mines in northern Minnesota, right here. Okay, and I have a friend that's from Hibbing. He says, if you're from Hibbing, you just know that Wednesday is blast day. I'm not sure if it still is. That's what it was when he was growing up. But can you imagine coming to Hibbing and those explosions go off that free up that rock that's then scooped up and processed in the process I was talking about and created into steel. So Minnesota has 3 ranges mainly, but only one of them is active. So there's the Gunflint's mostly in Minnesota, a little bit mostly in Canada, a little bit in Minnesota. The Vermilion, that's a lot of those underground mines. That's not active anymore. The Mesaba Range, which is Ojibwe for sleeping giant, and it's kind of like if you can picture somebody laying on their side sleeping. You can maybe make that out. It's kind of an impressive thing, given that we're looking at an aerial photo, and they didn't have benefit of that. They just had to imagine it by tracing it on the ground surface. And the Cuyuna Range down here. Northern Wisconsin, Upper Michigan has the Gogebic, the Marquette, Iron River, Crystal Falls, Menominee, so on and so forth. And I believe, I'm not sure if the Marquette still has 2 active mines or not. Most of them are inactive anymore. There was some controversy. Well, we go here, that's what we've already looked at. There was some controversy for a while surrounding some of these mines. If we look at this image right here, down a little farther, this is Silver Bay, Minnesota. And this is Lake Superior, and they used to crush that ore and take the tailings, the non-iron part of the rock, and just dump it into Lake Superior. And they found that there was some asbestos in those tailings, and it contaminated Lake Superior water. There was a while when the wells in Duluth you couldn't drink water from them because of fear of asbestos contamination. It came to find out that that form of asbestos wasn't as big a deal, wasn't as bad for you, wasn't really bad for you, and the contamination of Lake Superior was really not significant. But nonetheless, they don't allow them to dump the tailings in Lake Superior anymore, and Silver Bay no longer looks like this, although you can still see the tailings piles here along the shore as you drive along Highway 61 right here in that area, and this big facility is still there. They still do load some ships out of Silver Bay. So that the remnant of that is still there. I am going to try to put a 25-minute video on Moodle as well that chronicles the early mining in northern Minnesota. I think you will find it very interesting, and just how that transformation from underground to open pit surface mining occurred. As I say, it's an important thing when you consider mineral resources of Minnesota. Okay, folks, that's it. It's been a wonderful semester. I'm going to try to get, hopefully by the time you read this video or listen to this video, you will have the study guide on Moodle. I'm going to finish just by sort of addressing the obvious. This COVID-19 coronavirus issue has captured much of our lives and changed much of them. But it worries me a little bit, our response to it. The way that our lives have been changed, I wonder what the next thing that comes along that's going to justify in somebody's mind this type of alteration of our daily lives. Our ancestors, our predecessors in this country had some interesting things to say. I believe it was Jefferson that said, the natural order of things is for government to increase and liberty to decrease. And in their time, liberty meant freedom. Although they're not exactly parallel, it's pretty good. I think it was Benjamin Franklin that said, those who pursue safety at the expense of liberty will gain neither and lose both. So if I could paraphrase further, those who seek safety at the expense of freedom will gain neither and lose both. So a lot of people in this day and age will say, as they're saying goodbye to you, be safe. I'm not going to say that. I'm going to say, be free and have a good day.